So I pass it every day.
Yeah, exactly. My kids are in Ecoland. So.
Oh yeah.
That's
Okay.
it, yeah.
Yeah, we were thinking about that,
Yeah.
but okay.
Yeah.
Yeah, so
And what is going to leave home then when you go to Zurich?
yeah, and our daughter, we have two older daughters. I'm older than you think, maybe, but so yeah.
This came up once. I don't remember when because you
Yeah.
two were quite young. Yes,
Yeah.
it came up. Yeah.
You know, it's good
Yes.
shaping and creams and no. No, I have two daughters who finish university, so they have no real jobs. So they have to. We have to get up every morning and go to work. You know. That's
Earn a living. And your son, what is he planning to do? Does he know?
yeah, he will study as well, but it's not decided yet.
And where did they go and study in the end?
The daughters went in the Netherlands. Huh?
Yeah.
You know, we speak Dutch because we lived in the Netherlands.
Yes, I remember. Yeah, because when
So-
the Netherlands
so one-
came up.
Yeah.
Yeah.
Yeah, one is still in Amsterdam. She works there in Haarlem,
Yeah. Yes.
and the other one is in Barcelona.
Okay. Oh, nice.
So yeah, let's see. Exciting
So
development.
just decided which way he wants to go.
Probably economics, he says, but
Yeah.
let's see.
What are the country options to study?
Yeah, he
Netherlands
was
as
born
well.
in the Netherlands. Yeah, he speaks
He's also
Dutch.
interested.
Yeah, but
They have
also
international programs as well, right?
Yeah.
Yeah.
So he should handle, should be able. Yeah.
Okay. Yeah.
Good. But I'm sure we will continue to
Yes,
collaborate. Yeah.
Yeah.
Okay. Hey, thanks a lot. Yeah. See you around.
Yes. When are you leaving?
I have a few more days.
Okay. Perfect.
See
you.
Went very well. Yeah, I think went well. Was a small setup here, but I think it was interesting. We had a couple of questions.
Conversation.
I also feel so. Yeah, no, thanks for contributing a lot. Huh?
People were online.
There was online. I will check with my colleagues how many were online.
Yeah.
When we started, it was only 6. But okay. But with YouTube, I'm not sure if you really see this always.
No, I don't think you see always.
You said 6. I don't know how he knows. So I will check this out. But yeah.
Yep, great.
To be continued next year, I'm afraid. Huh? Yeah.
Yes, I'm here for
Okay.
the
So I won't say goodbye to you.
Yeah.
Cheers.
Are you
I,
heading
I
back?
know. I have a few more days. Then.
Yeah, okay, great.
Unfortunately.
See you around there. There is a
Thanks. See you. Bye bye.
Sorry, it's fine. Yeah, no, thank you. And I'll just go and keep that going.
Test.
Check, check.
Hace el otro. Gíralo.
Side event.
Side event, or is it meeting room?
Side event, yeah, meeting room for side events.
Meeting room. Get out and go straight.
Where the restaurant.
Yeah.
So I have to turn this at the very end.
Well, it's before the plenary. It's between the pavilion and the plenary. And there's all the meeting room. If it's meeting room or side event.
Side event.
That I don't mind.
Where is this restaurant area? The restaurant. That,
The gastronomic center.
yeah, the center.
There.
I turn
Get out of here.
plenary.
Yeah. Before plenary.
Check, check, check.
Have my slides. Have my slides. Okay.
Good morning, everyone. We're going to get started right on time.
No, wait.
Oh,
Yeah, no.
Good morning, everyone. And so welcome to this event on data that delivers, the why investments in systematic observations matter. We are going to try to shorten it a little bit because, in fact, last night we heard that there are going to be negotiations on the research and systematic observations agenda item taking place at noon. So we'll aim to end 15 minutes before noon so that we can, many of us can go to those negotiations. So my name is Albert Fisher. I'm director for WMO of the Integrated Global Observing System, and I'll kick off this event. And we have some opening remarks from Sebastian Carvalho, who is Deputy Director of Sustainable Production Agency of the Agency of Sustainability and Climate Change of Chile. And he's here giving remarks on behalf of the Undersecretary of the Environment, Mr. Peruano of Chile. The floor is yours.
Thank you.
Thank you. Thank you for your words. Nice to meet you. In recent decades, climate change has emerged as one of the most pressing challenges of our time, affecting not only natural ecosystem, but also economies and societies around the world. This phenomenon, driven by human activity, has led to an undeniable rise in global temperatures, altering weather patterns and triggering extreme meteorological events. In this context, the systematic observation of the climate becomes as essential necessity for countries, as it provides fundamental data to understand and mitigate the effects of climate change. Given the growing climate vulnerability, it is imperative that countries strengthen their capacities to carry out systematic climate observation in order to better understand the evolution of climatic phenomena and design evidence-based in public policies, such as the NDCs, while anticipating impact in critical sectors like biodiversity, water, and health. The continuous and accurate collection of climate data enables countries to identify trends and variations in the climate over time. This is crucial for the development of effective policies that address both climate adaptation and mitigation. Without reliable data, it becomes practically impossible to make informed decisions that protect both the environment and vulnerable populations. The lack of information can lead to ineffective or even counterproductive response. Furthermore, climate observation is vital for the planning and management of natural resources, including water, agriculture, and energy. With climate change, the ability and distribution of these resources are deeply affected. For example, monitoring rainfalls and temperature helps farmers adjust their practices and prepare for potential droughts or floods. Without information, country risks facing food and water crisis, directly affecting the safety and well-being of their citizens. Countries also need to strengthen their technical and scientific capacities to carry out climate observation. This requires investment in adequate infrastructure, advanced technology, and the training of specialized personnel. Likewise, information exchange and international collaborations play a key role in building networks that facilitate access to climate data from different regions of the world. This collaborative approach not only improves data quality, but also fosters a shared sense of responsibility in the fight against climate change. Another essential aspect is the role played by local communities in climate observation, integrating traditional and scientific knowledge in climate monitoring can provide a richer and more comprehensive perspective. Communities that depend directly on their local environments are often the most affected by climate change and can offer valuable insights into the climate variation that they experience. Including this voice can enrich observation efforts and help develop more effective response. Today, these systems are gradually threatened by the decline of in situ monitoring networks and satellite missions, lack of data accessibility, insufficient financing, and potential interference caused by frequency allocation for mobile phone networks within the International Telecommunic Union. It is important that parties fulfill their commitments in this area under convention. We invite you to share information to support meteorological, hydrological, and observation infrastructure service in developing countries, and to finance the expansion of the system observation financing facility to more nations. This will help strengthen the global basic or observing network, which is an essential global public good. We also invite you to ensure the continuity and capacity of Global Basic Observation Network and other programs that comprehensively access global observation capacity and coordinate observation across their value chain. It is vital that the resulting information from data rescue to prevention and supply be interoperable and useful for decision-making that enables us to achieve the goals of the Convention and the Paris Agreement. In conclusion, systematic climate observation is indispensable for countries to face the challenge associated with climate change. Therefore, it is necessary to invest in climate monitoring infrastructure and system, strengthen scientific collaboration networks, and ensure that the information generated is accessible, interoperable, and useful for national decision making. As the world continues to grapple with the realities in climate change, it is crucial that all countries recognize and prioritize the importance of such observation. Only through an informed and coordinated approach will it be possible to adequately confront this global issue and protect future generations. We would like to conclude by highlighting an initiative that we greatly value and consider an example of what we hope to see. The World Meteorological Organization is preparing a concept note for the project, an integrated system to assess hydrological status and outlooks in order to support key economic sectors and vulnerability communities in South America to adapt to the climate change and strengthen resilience. To discuss this initiative, a meeting will be held in Asunción, Paraguay in December with the participation of the national authorities designated to the adoption fund from South America countries. Thank you so much.
Thank you very much, Mr. Carvalho, and thank you for emphasizing the importance of systematic observations for national action, for policy action, and the importance of the financial flows and investment into them. So without further ado, I hand over to the steering committee chair of the Global Climate Observing System, Thelma, for the next segment.
Thank you very much, Aut, and thank you for being here. I'm going to be very brief, and in particular because I have three great speakers that will provide some very interesting information about the trends. This session is about trends. So please, if you want to know a little bit more than I can provide here for GECOS, look at our flower outside, and then you're going to know that there are lots of things out there. So anyway, if we can have the next slide. Yes. So basically, we work towards observations, sustaining and enhancing and sustained climate observation so as to provide enough evidence for us to evaluate the status of the climate and also to predict the future of the climate, assess risks, and also to enable us to attribute, for instance, some extreme events to the underlying causes. The next one. Well, we have three panels. We have two representatives here, one from the atmosphere, one from the terrestrial, which is Martin, and also Karina from the ocean panel. So the three panels define what we call the essential climate variables. So today we have 55 essential climate variables. So basically you have the definition, what it is, critically contributing to the characterization of the Earth's climate, and all the 55 are here for all the elements of the climate system, atmosphere, ocean, land, and including hydrology and also cryosphere. So the next one, please. Yeah. So I think that one important element of GECOS is that every 5 years, it has a cycle assessing gaps in climate observations. And this is included in a status report. And also identifying is not enough. We have also to indicate how GECOS could facilitate actions that would fill those gaps. And that is done in our implementation plan. This year, extraordinarily, the steering committee, Aida is here, is one of the members of our steering committee. So extraordinarily, we decided that we are going to have the status report and the implementation plan together in 2027. So that's going to be something different. And also we report to the systematic research and systematic observations to the UNFCCC. So those that are following this agenda know that we have a very nice paragraph that says the conditions of the GECOS today and concerns that we have been expressing that some in situ observations are declining. So next slide, I think, shows one example of radio sound reductions that the upper air network, which you can see is decreasing in terms of in situ observations. And obviously, this means that some of the events cannot be properly assessed. I think this is the end of mine. Yeah, but anyway, let me then introduce Clement, because I don't want to leave my presentation with bad news only, because I mentioned that this in situ decline might not be necessarily followed up, but what we see in our observations, at least in Europe. We don't know what's going to happen in terms of observations in other parts of the world. But with that, Martin. Martin is, I said, is the chair of the terrestrial. Oh, no, Clément. Ah, Clément. Yes, indeed. So Clément is from the European Space Agency. So he's going to tell a little bit of the trend, past trend, and the future that we are foreseeing for the satellite, Earth observation satellites in Europe. Thank you, Clément.
Thank you very much, Thelma. Right. Satellite Earth observation has a unique capability of observing the Earth everywhere, all the time. They permit to take the pulse of our planet. And from observation to inform decision-making, they are an integral part of the solution. At the European Space Agency, we develop world-class satellite Earth observation system together with European and international partners in order to address scientific and societal challenges. On this slide, you have all the missions we have developed or we are currently developing in our three main lines of activity. Pure science with the Earth Explorer, meteorology, operational satellite used every day for weather forecast, and in the middle, between science and operation, the Copernicus program of the European Union and its dedicated fleet of satellites, the Sentinel. I would like to draw your attention to the timeline on this figure. 2025, it's here. It has been a year of launches for ESA. Earlier this year, we launched our seventh Earth Explorer, biomass. I will come back to that later. We've launched Sentinel-1D last week, and we had two meteorological satellites, METOP second generation with Sentinel-5 on it, and MTG as well. Very where trees store most of their carbon. Next slide, please. We are also working on the evolution of the Copernicus space component. And we have a lineup of 6 extremely interesting missions. CO2M to look at carbon dioxide. It will be launched toward the end of 2026 or rather beginning of 27. LSTM and CHIME to look at food security and water management. ROSE-L and SIMMER to look at monitoring land and natural resources. And CRYSTAL to look at the Arctic. One more, please. And we are also preparing the next generation of the Sentinel data for continuation and enhanced observation. My team is implementing ESA's climate program. It's a research and development activity that main objective is to develop global scale, satellite-derived, long-term time series of key components of the climate system, the essential climate variables as defined by GCOS. To do that, we put together 40 years of ESA Earth Observation Archive together with data from third-party missions that are not owned or operated by ESA, as well as operational mission. The Climate Change Initiative of ESA is a direct response to the UNFCCC need in observation. In 5 years, 10 years, 15 years, we will continue developing those climate data record, and we need the guidelines from the scientific community through GCOS to prepare already now the integration of all those future missions. Thank you very much. Oh. Obrigado.
Thank you, Clement, for being sharp on time. So now the next speaker is Martin. And Martin is going to talk a little bit about how it can better support terrestrial networks. Unfortunately, we didn't have too much time to talk about GCOS networks. And so how can we better support the terrestrial networks and combine them with the satellite data or satellite monitoring to enhance our ECD's monitoring as well in an integrated way? So Martin, it's all yours.
Thanks. Thank you, Thelma. Oh, I'm trying to compete to the people next door with my voice. Thanks for being here. So Thelma asked to talk about trends, and you will get two trends from my side when it comes to the terrestrial panel and the terrestrial observations. Because of course, a lot of our essential climate variables we monitor with space-based data, but most of them we monitor from a combination of on-the-ground measurements with space-based data. And we have put a lot of emphasis on enhancing GCO-supported terrestrial networks. And what we see with these networks is some are running really well, like the Global Glacier Observing System. Some we were able to move from a research to an operational stage, like with the soil moisture network. And some we see that they struggle. And one of the typical, this is data availability for, this is the river discharge data, right? And we often see in these network and data availability a bit this hump shape, right? Where you see a bit of a peak, and over recent years, we see a bit of a decline of observation. That's a typical pattern we see in quite a few of those. And because these data are coming from countries, and some networks are just not able to be supported actually improve the ability to also measure river discharge, we were able maybe to complement these ground-based observations and basically overcome this bit decline in observations from a combination observations to keep up the long-term climate data record. So that's one important trend for us. The second one, next slide, please, is a bit more of a complex one. And I put the complex leg on purpose. We are here close to the Amazon, right? We do see forests changing in different ways by different drivers. We have the carbon impacts of degradation and regrowth, and we measure that from space with various observing systems, but also with a lot of in situ measurements from traditional forest inventories to laser scanning and all these kind of things. And so what we are seeing as an important trend is that the global space-based data are increasingly integrated with these various ground-based systems, which are coming often from countries, countries running these in situ observing system to make them useful for national estimation and reporting purposes. So understanding what's the impact of different activities on forest carbon stocks for the greenhouse gas inventory, for example, or to support climate action is an integration task where we see the global ECV records can be leveraged with the national systems to really also improve national estimation. And we are, for example, actively working with Brazil. We had a workshop just 2 weeks ago at INPE where we really discussed these kind of things, in particular when we talk about the forest carbon sink and what's the effect of regrowing forest and restoring forest on the global carbon sink, which remains a large uncertainty in the global carbon cycle. So these are my two trends. There are a couple of more, but at least I want to leave you today with these two.
Thanks, Martin. Yes, great. So we are going to have a final presentation from Karine. She's going to talk about the interconnectivity of the climate system from a Earth system approach. So Karine, all yours.
Thank you very much. So I take the opportunity to provide you an approach looking at the entire physical sense with respect to the functioning of the Earth system. And so this is a picture. So major Earth system cycles like the carbon cycle, like the energy cycle or the water cycle are those which ensure the transfer of carbon, water, other tracers, and energy, mostly in the form of heat, around the climate system. And these are the elements, together with the variation and its natural rhythm, to sustain life on Earth. Because we have a wide range of observations, from direct observations, remote sensing observations, combined with models, reanalysis systems, and models, we have an understanding of these cycles. And this also shows how essential the observations are in order to ensure that we are able to understand, to monitor this complexity and this natural rhythm of sustaining life on Earth. Today, then, on this natural rhythm, we have a long-term pressure from climate change which is affecting all those cycles. And these include, for example, the accumulation of carbon, because we have specific carbon sinks because of the greenhouse gas emissions, affecting increases, for example, in the ocean, which has consequences like acidification of the oceans, so also the land sink. Then we have the energy cycle. Because of greenhouse gas emissions, today the Earth is out of energy balance. And this is because it is receiving, less heat is leaving the system as compared to what we receive from the sun because of the greenhouse gas emissions. And this has also consequences. Because of this, there's an accumulation of heat in the climate system, warming the ocean, warming the atmosphere, warming the continents, and melting the ice on Earth. And any changes of those changes are implications for the entire system and also the socioeconomic implications, as we have all assessed in the IPCC. And then the water cycle. Also, the water cycle is affected, and observations show us that the water cycle there's an intensification of the water cycle with very wide-reaching implications, such as, for example, implications on monsoon precipitation or dry and wet events. So we have achieved a huge understanding, a deep understanding on the functioning of the Earth. But we also see these changes. So we see, for example, changes in the Earth's energy imbalance, which is currently increasing over the past 2 decades and even accelerating. And we need more observation to understand why this is happening. We need to understand to monitor these ongoing changes. So we have to sustain our current capabilities. We have to increase our applicabilities because we have to understand the implications, not only at global scale, but going to regional scale, for being able to alert, for being able to anticipate, and for being able to improve our capabilities to project those changes for the future generations. So I would like to close this, this short angle from the Earth system cycle with a statement which has been done for the global ocean observing system, but which holds for the entire observing system. That is, without data, policy is going blind. And I would like to get one step further. Without data, research is going blind, and we reduce our knowledge and our capacities to understand, anticipate, and alert. Thank you very much.
Thank you very much, Karina. And I have to close, but not without saying that from the sample you have had of these brilliant presentations, you see how important it is to maintain GCUS alive, working, and enhancing every time climate observations for the good of the planet. So thank you very much, Albert.
Thank you very much. And thank you for that, those important messages. And we move from the global perspective in the next segment to the national perspective. So I'd like to invite Osvaldo Moraes to moderate the segment. And let me ask Aida, Amable, and Gabriela to come up to the stage, please.
Thank you all. Well, are you prepared to live in a new world with such temperature? Yeah, we need to be prepared for that. Oh? Well, let me to say small words as an introduction of these sections. I am a theoretical physics, and I took my PhD in the 80s, trying to describe the interaction between the surface and the atmosphere. And at that time, the number of observations that you had were so small that all the models that you will develop at 40 years ago, now we understand how weak they are. So, and the most important process in the atmosphere to predict the extreme meteorological events is the correct description of the planetary boundary layer in the atmospheric models. So there is no doubt that observations are so important. Well, we have 3 speakers now. Oh, thank you so much. You have 3 speakers. The Saki Okuko. First, let me to. Yeah, okay. So let me to apologize if my expression of your name is not correct, okay? Well, the first one is the Aida Dayong Nyang. She is director of the National Agency for Civil Aviation and Meteorology from Senegal. The other one is Mabel Garrigue, Director General for Meteo Rwanda. And the third one is Blatter Gabriela. She is the Principal Policy Advisor at the Federal Office of Environmental Switzerland. I got three motivation questions for them. One moment, please, to assess my motivation questions. Well, from Nicole, the question is, from your perspective, how does Meteo Swiss see international cooperation help ensure that the data from developed countries can feed into global forecasting system? The other question is for Amable. Rwanda has been an early champion of open data exchange and regional collaboration in East Africa. From your experience, how does JICOS and SOF support data sharing and help countries like Rwanda building a sustainable observing system? And the third one is for Aida. What's the value of JICOS for you? How can a global infrastructure provide support for at national scale? So who would like to start? Yeah? Okay. Thank you.
Thank you very much. First of all, I'd like to appreciate the previous presenters for the good work and information. I can just start with the trend. Everyone just is scared about the trend in terms of the data sharing being received to the global platform. And in addition, our forecasts, the models being used, as moderator is mentioning, they are not performing well currently. We can just ask ourselves why those models are not now no more accurate as before. I think the fault is coming to everyone. We are not providing the data, the required data to feed those models. And then we are just looking for output from the models without providing anything. It is now correlated to the trend which has been shared, the declining in terms of the data. I think from this perspective, SOF now can be the response. We can be optimistic that the trend is going to change. Let me use an example. Within our region, starting from my country, from SOF, we benefited from some facilitation to acquire automatic weather stations and Apaya stations. Currently, in addition to the stations being reporting to the global network, through SOF, now we have 3 additional ones compliant to GBON. Now, even if Rwanda is a small country, but the terrain is somehow complicated, reason why we have to add more stations in order to have, even in return, good products from models. Within the region, we do expect from SOF, when I'm measuring the region, we can just have a look on five countries: Rwanda, Uganda, Tanzania, Ethiopia, and South Sudan. Through SOF, can you imagine now, we can just have a reference to a global research center like ECMWF. The data they are getting from those five countries, they are just a little, but through SOF, within those 5 countries, we are expecting to have more than 150 automated stations installed using SOF funding and more than 15 upper air stations. Can you imagine now how the network is going to be looking like within only that particular region? And then if those global research centers, such as ECMWF, if they're just getting those data within how now the products you are getting from those global research centers are going to be performing. We do have a baseline, almost no data from Apaya station being shared. And then in perhaps for the forthcoming years, more than 15 Apaya stations reporting compliant to GBON. I think now the trend you are just scared of, now it is going to, we do have now a response through SOF. And even the models which are not performing well currently, we do expect now they're going to have, the accuracy is going to increase. In return, the users from all socioeconomic sectors are going to be served on time and then make proper informed decisions. I think that is an overview for what we do expect, and then what we're just experiencing through SOF. Rwanda's a front-runner countries, which is benefited from SOF. We are so much eager to even to help other countries to in order to make sure we speed up all the processes regarding the data sharing. Also, this transition from GTS transmission to WIS toolbox, it is now easier to add more stations apart from the commitment from SOF. We can just even add more station in addition to what SOF is offering. Thank you very much.
No, I got three. Well, Nicole, I'm so sorry. Well, my heart is. Well, Nicole, I will pass the floor for you, and I will repeat the motivation. I will repeat the motivation questions, okay? From your perspective, how does Matthew Swiss see international cooperation help ensure that the data from developing countries can fit into global forecasting system?
I think for us, it's really important. We have like a most recent example for that. Only last week in Switzerland, we presented as Meteo Swiss the new climate scenarios for Switzerland. And they provided a really detailed example how the climate will develop for Switzerland. According to different scenarios worldwide. And so I think it's a very good example to see that if you have like a lot of data over the globe, it's possible to have like really small scale modeling, for example, for Switzerland, for alpine valleys, and we can now make really detailed sayings about how it's going to be in different regions, even in Switzerland. And it was mentioned a lot that it was only possible because of GCOS, because we have this data provided long-term wise over the whole globe to do that. And if you compare like the old scenarios from 2018 to the ones from 2025, it's not like that they differ really much, but they're really more detailed. And this is like thanks to GCOS and to have like this global data on a long-term scale.
Thank you so much, Nicole. Now the third speakers, the last but not least, Aida, what's the value of GICOS for you? How can a global infrastructure provide support at national scale?
Thank you. I see two parts. One is the value of GCOS for me, and the other part is how GCOS support national action. Now, for the first part, I can frame my answer in 3 points. The first one, GCOS is, it has been said, GCOS is the backbone of global climate science. The ECVs that have been shown here are the foundation for climate modeling and also IPCC assessment. 2, GCOS ensure coordination and interoperability, linking national and regional networks into one global system. And it set measurement standards, identify observation gaps, and promote open data exchange. And third, GCOS connects science to policy, its observations are relevant to the global stock takes and other UNFCCC processes. In short, I can say that GCON turns fragmented national data into global knowledge. So the second part of the question, how GCOS support national actions. First, I think GCOS, there are many ways. GCOS help countries to strengthen their own system, not by replacing them, but by providing a framework to align to global standards. By setting also shared methodology and metadata standards, you can ensure that national data can flow in and out the global systems. Most of the data in GCOS are also used for global modeling. So in turn, we got better reanalysis, better models for forecasting, for early warnings, and also global data sets that are consistent. GCOS also amplify national voice internationally through the implementation plan and status report. GCOS identify observation gaps, and this raise awareness and convey local challenge to the international community. I think also GCOS even can help to more consideration at national level. If I take the case of Senegal, the agencies that are providing data, for example, for atmosphere, ocean, and land are under different ministerial departments, which are different from the Ministry of Environment, which is the national focal point for UNFCCC. There are a lot of initiatives going on at the policy level by the Ministry of Environment, including the National Climate Law. But through the lens of GCOS, we were able to emphasize the fact that we need to include systematic observations in the climate law. Not only systematic observation, but also a unified data set for meteorological, hydrological, and ocean data that will help us to deliver more research at local level and to build resilience and to support climate action at national level. So this is what I wanted to say about this question. Thank you.
Well, thanks a lot for your presence here. It's really a pleasure for us of Brazil have you here. For this is a great opportunity to learn with your experience. And now I return the floor for you.
Thank you. Thank you very much. And thanks for the important witness from the national perspective. So let me invite you to sit down and we'll close with Marcus Repnick and Florence Rabier. You could join me on stage. So Florence, I understand you have a few slides to talk about the impact of observations on forecasting. So we can bring those up.
Thank you. Okay, so I will be very short and just will present a few plots actually. So this is the observations we receive and we use in the European Center on a daily basis. As you can see, a lot of observations some places, not a lot of observations somewhere else. This poses a problem because we already discussed how in situ observations are the basis of forecast and early warning. They also used to assimilate satellite data, to calibrate, validate, and this is also something we use very much in forecasting. And of course, they monitor the climate. Next slide, please. So if through SOF, we can add observations there, which are the least developed country and the small island developing states, this is the sort of impact we get in terms of reducing the forecast uncertainty, up to 30% in Africa, up to 20% in the Pacific Ocean. That's not negligible at all. So as you could see, by filling the gap, we can increase the forecast quality. Next slide, please. If we go further and we include observations in all ODA countries, then we have more data points, a much larger impact as well. Now, most of Africa is improved,
the Pacific as well, but also we see other regions like the Indian Ocean, like Latin America, and we can see a bit in Asia as well. So this really would give a much more comprehensive and much better observing system for better forecast, better climate monitoring. That's it. Thank you.
So just a few remarks from my perspective. President Lula called this a cup of truth. And there's many scientific truths that are really important to bring to the global negotiations in terms of record greenhouse gas concentrations in the atmosphere, in terms of temperatures. We're on track to be the third highest year on record behind last year's record. And these are really important truths to bring to the negotiations, and they depend on the systematic observations in all the domains, in the atmosphere, in the ocean, in the terrestrial domain, including the cryosphere and hydrology. So that's the first point. The second point is that we need investment in these observations. While we see great potential and increases in the satellite observations, we do see in a number of in situ observations a decline and persistent gaps. And we need, therefore, that investment both at the global level in frameworks like GCAS and in the national level to really help countries fulfill what is a global public good. And with that, I will hand it to Marcus for a few words from SOF.
No, thank you very much. Could you just bring to the next slide? I mean, first, it's a real pleasure to be here as part of a community, for committed community with one single purpose, to strengthen the systematic observation across the globe. My main message is we need to cry louder. We need to go beyond our community. We need to bring this into the negotiations. So please also help us in the negotiations. We need to break the wall between RSO and finance. Now, it's for me heartwarming to see how countries like Rwanda or Senegal really having committed to close the data gap. And I will close just with one graph. SOF is already providing initial support to 61 countries. 18 countries are already in investment phase. Our support with 18 countries, we're covering almost 30% of the global GBON, Global Basic Observing Network gap of all LDCs and SIDs. Our target is to add 32 more countries by 27. We will be able to cover already 60% of the data gap in LDCs and SIDs, coming close to what you, Florence, just showcased. So I want to just close saying thank you very much to the leadership of the countries. We are talking here, but it's the hard work of you, Ida, of you, Aimable, and your team in the countries contributing to a global public good. Thank you to being part of this community. I feel honored. I feel privileged. But please help us to cry louder. We need to actually strengthen the systematic observation system across the globe, bring us into negotiations. And great to be again here with friends from Thelma co-hosting this GCAS, to Osvaldo and many of you. And with this, I would like to close this event saying thank you very much to Albert for having facilitated this, Florence and colleagues who are with us. Thank you very much, and see you in a few minutes in the negotiation room. Thank you.